Hello, everyone. Welcome to this AI CoSpot webinar panel discussion. It is themed around digital transformation in manufacturing, a roadmap to smart factories. We are delighted to have participants come from all over the world joining us for today's webinar, along with a great speaker lineup. Now to begin with, myself, I'm Arvind Kannan. I'll be a host for today's webinar. I joined by Nitin Naveen, who's VP of Innovation Strategy at AI CoSpot, and a couple of our colleagues, Archana and Naveen, will be assisting in this webinar to keep it lively. Our focus is today on navigating the path to smart factories through digital transformation in manufacturing. We'll deep dive into the strategies and technologies driving this evolution, optimizing processes, and enhancing efficiency across manufacturing landscape. But before we dive in, let me provide you a brief overview of AI CoSpot. We are a 3-year-old company with mission to be #1 AI-driven community all over the world. The focus is to provide deep dive into all of the sectors wherever the technology is there. Every month, we are having different themes, gaining momentum month on month, so that like-minded people like you can be part of the same and supporting and growing and making it a huge success. Our mission is to serve as a hub for information regarding Industry 4.0 technologies. We'll continue to do industry-packed webinars and hybrid events. The knowledge repository will be made from the reliable data through industry thought leaders and subject matter experts. We'll enrich the digital content through videos, blog, podcast, and newsletter to shed the light on ever-evolving industry. So I request all of you to go through our website, aicospot.io, for further updates. Also like our social media handles, which will keep you all updated on what we propose to offer in coming months. And special thanks to our community partners for today, which includes Grain Company, Dairy Farmer of America, Coherent Corp, and InfoVision for their invaluable support in making this webinar a huge success. Now, let's move on to our esteemed speakers for today who have generously dedicated the time and knowledge for today's discussion. Let me introduce the panel speaker one by one. We have Samir Nagpal, who's the Chief Business Officer for Retail, CPG, Logistics, and Manufacturing Business at InfoVision. And we have Jinesh Gandhi, who's VP of Engineering at Grain Company. The third speaker, we have Hans Burgos, VP Assets and Technology at Dairy Farmers of America. The last speaker, we have Ananta Ganga, who's the Chief Information Officer for Coherent Corp. Before we begin, a quick disclaimer I would like to put. The views shared by the speakers are the personal one, and it's not related to any organization which they represent. I'll quickly pass it on the stage to Samir to drive this panel discussion. Over to you, Samir.
Thank you, everyone. And good morning to everyone. Thank you for joining us in this panel discussion on the digital transformation in manufacturing. We really appreciate Ananta, Hans, and Jinesh for being the esteemed panel on this discussion. So, with that, I'll kickstart this discussion. So, I'll give you some data points actually. I'll start with that. As per a very recent Gartner survey, most of the CIOs in the manufacturing industry are focusing on, I think, the innovation or the transformation part, which is attributed to, like, if I give the percentage split, 22% of the ideas go into the growth of the companies, 25% in the cost optimization and the efficiencies, and 16% of them focus on the transformation and innovation in the manufacturing setup. So I think digital transformation has become a very, very key part of our overall strategy. And I think what we are trying to do is, I think what all of you would have heard the idea about Industry 4.0, which is talking about all those things. So I'll probably kickstart my discussion with some of the points that are pertaining to the 22% on the cost optimization and efficiency. I think, and when I talk about cost optimization, I think there are multiple things. So Jinesh, I will come to you or start with you on the cost optimization part of it. So tell me, Jinesh, how are you handling or how are you managing the digital transformation when it comes to the cost optimization in your setup?
So good morning, everyone. To begin with, overall, in our business culture, we look at things as from the priority perspective: safety, quality, delivery, cost, and then growth. Right. So whenever we start any new initiative, it has to go through the lens of these things. Now, If I specifically focus on the cost aspects, we divide and distribute between different functions. So, for example, supply chain, operations, as well as engineering, where I belong, we have different targets that we have to achieve in order to be efficient, in order to combat the inflation, and in order to stay competitive with the margins. So on the cost aspect, from engineering side, we look at what we call VAVE, which is value add and value engineering, in which we are looking at design, material, and different ways of building the product. And if we focus on specifically on the manufacturing side, the overarching vision we establish is by creating what we call EVSM event, which is Enterprise VSM event, through which we perform a Kaizen event, and we identify all the processes within manufacturing where we see areas of improvement. And then what we do based on that, obviously with some data collections, we devise a plan, what we call a future factory vision, or a continuous improvement roadmap for next year. Right. So based on that, events are planned at least once every month, in which we are looking at, let's say, one assembly line for standard work events, another assembly line for, let's say, a SMAD event. So depending upon the complexity and the problem that each area within the manufacturing that we are facing, we have a different strategy. Now, let me add where the digital transformation comes into this picture is we don't have an overarching strategy of, okay, let's implement digital transformation across the board. However, we are cognizant about leveraging specific tools that resonates with solving specific problems. So that's how we go ahead and implement the layer of transformation within the continuous improvement activities that we are doing.
Thank you, Janesh. Thank you very much. And I'll pass on the same question. Probably I'll discuss with Hans a little bit. So Hans, I think from your from a dairy and from the farm to the store kind of setup, how are you planning, or how are you implementing the overall digital transformation, specifically pertaining to, let's say, cost optimization or kind of productivity improvement? How are you implementing that in your area?
Good morning, everyone. Yeah, when you look at our overall supply chain, and we call it from grass to glass, so from the cow that produces the milk to the consumer that drinks or eats our products, there are different areas of focus. Of course, we have the farm side of things, where the farmers do a lot of optimization, not only in productivity, but also related, of course, to sustainability. But when you look at our manufacturing landscape, we have 83 factories in the US and making a broad variety of different products. And it makes also that we don't have one overall strategy, because the factories are so different. What is very important for us is that we remain competitive on a global scale, because with the increase in milk production in the US, a stagnant consumption, and a growing gap between supply and demand, a lot of our milk in the future has to go to global markets. So we need to be competitive on a global scale. How do we deal with digital transformation? We try to compare the performance in our factories on 3 levels. That is within DFA competitiveness, that is on US dairy scale, but also on a global scale. And for that reason, we collect all data from all our factories, and we started in the business group Ingredient Solutions, where I'm working, to get all PLC data in a giant data lake, and run reports, so that we can compare factories, compare product lines, draw reports, but also give feedback to operators that run our factories, how they can improve. Also, we implemented in a number of our factories a tool, what's called advanced predictive controls, where through digital we can really look into unit operations like an evaporator or a spray dryer, and optimize based on the number of parameters that we collect and do that real time.
Got it. Thank you. Thank you, Hans. Ananda, I'll come to you. I think I want your perspective on this one before I jump into details of. I think there are multiple topics I want to cover as part of the world, but let's start with the optimization or the cost reduction kind of stuff.
Yeah. Good morning, everyone. Coming from an IT side and helping business, right, or innovating on the business side, 3 areas we focus on: operations, productivity, and quality. So we are a complex manufacturing with vertical integration. So that how do we optimize our inventory, supply demand sensing, and how do we adjust? So providing that visibility. And second area is in a vertical integration. When the product is moving from factories to factories, how can we have a genealogy, traceability, end-to-end traceability, and also do a network analysis and make sure that we can sense it and then fail fast. So in a production environment, in the fail fast, looks like a negative thing here. Fail at the first step is a much better option than fail at the last step. And then you have a huge wastage, right? Or the yield losses, the shrinkage.
Yeah, we call it fail early, fail fast.
Fail fast, exactly. And other one is on the quality side, having those parametric data analysis, quality collections, and able to give that visibility, and then make the analytics on top of it. So predict DPPM, defects per million. So we know we can predict it. So that's the IT's role in helping and in using the technologies, the data, and the AI or ML models to help the business.
Thank you, Ananda. So all of us discussed about one thing, and we all were talking a little bit about some of the points that I'm going to I'm planning to go into the details, starting with let's say data. So I think all of you talked about the data part of it, right? So and data is a big area basically. I think we can start with the data gathering, data analytics, and the kind of modeling that we are doing, and what are we getting out of it? How are we using the data for our future? So I think since Ananda, you also mentioned about data, so I'll go in the reverse order now. So tell me, what are the initiatives that you're taking on the data side when it comes to manufacturing? And I'm talking about the data gathering, data kind of processing, and what are you using from a data modeling standpoint, actually?
So from data, particularly in this case, taking out manufacturing data in a complex manufacturing, genealogy and the parametric data collections are very, very critical. And number of times you can observe that people talk about reports, dashboards, but often people not look at what is the back-end data quality. Do we have a data definition, data dictionary? Those are the critical challenges, and it's not, there's no perfect answer. It's a continuous improvement. That is the biggest challenge, and enabling the business and getting to an understanding of a standard definitions of the data and able to connect the data, right? We have the data in multiple locations, multiple facilities. How do we connect and make sense of the data? That is our biggest effort and the challenge.
Okay. So Ananda, I'll probably go one level deep on that side. So there are various ways of collecting data. So what kind of data are you seeing in the industry being collected? So one is from, let's say, for example, data from the like machines kind of stuff, right? That's a data that you generate from let's say a sensors, or I think I'll go a little later. I'll go to the other technologies like IoT and all those things. But that is one kind of data. What other data that you collect from them, which you make use of in your let's say data reports and all those things? What are the data that you're generating out there?
The data is collected from multiple sources. One is sensor data coming from the machines, and other is the manufacturing execution systems, which is the manufacturing tracking, and the financial data, which is connected to the manufacturing, the cost accounting and financial accounting data from ERP systems, and our sales and marketing data. the demand, sales and operations planning from our CRM system. So this is a comprehensive data from a reporting perspective, plus the master data that's coming out of the PLM systems.
Got it. Okay. Thank you. Thank you, Ananta. So Hans, coming to you, because you also mentioned a lot about data as well. I want to kind of talk to you about what are because your industry is where I want to figure out. I'm very inquisitive about that, the dairy industry. What are the data that you are gathering and how are you using that data? Because from grass to glass, it actually requires a lot of data collection and data integration from creating that visibility. I'm very inquisitive about that, Hans.
And that determines very much on where we are talking about in the supply chain. But when you look at first on the milk collection part, and we are a cooperative, so our mission is to create value for our farmer owners, and that starts with having reliable operations and collecting the milk from those farmers 7 days a week, because cows don't have weekends. So our factories operate 7 days a week. What we do, it's a huge logistical operation, because we have around 5,000 milk trucks, each containing between 50,000 and 70,000 pounds of milk per day. That has to go to a factory. So we collect data from the milk, from the farmers, where to send which truck to collect milk, and then based on the composition of that milk, to bring to which factory. Because when you make cheese, you want a different type of milk with a different composition than when you make milk for consumption. So that's one part where we collect data to optimize our transport of milk. Secondly, what we do in our factories is that we collect a lot of data, and I fully agree with Ananta. It's not the data collection part what is the challenge, but how do you make sure that what is process A in a factory is similar as process A in a different factory. So we start with asset tagging, so to make sure that all the data that we collect from valves, from motors, from silos that we have, that they are all based on the same coding. So when we collect data, so that we can compare information that is based upon data. What we need also, what's very important, because we are a manufacturer of food and beverages, that we can track and trace throughout the whole chain. That when we make a milk product or a powder or a cheese, and something is wrong with it, that we can trace that back to the farm that supplied us the milk. And it is really a challenge to collect all the data, because you need 3 hours after an event has taken place, and you have a quality defect, we need to show which farm supplied that milk. And that requires that you collect data throughout the chain to make sure that you can follow and monitor that flow of goods throughout your supply chain.
No, thank you, Hans. And I believe because of you are a regulated industry because of the dairy company and everything. So it's a food regulation and everything. And I think the data collection becomes very key for your industry specifically, and which actually also helps you preventing a lot of things pertaining to the wastages and to things going wrong in terms of the expiry date and all those things. I think the data becomes very important for you as well, actually.
Absolutely.
So Jinesh, coming to you. Again, the same question that I will probably bounce off you. Data. I think you mentioned about data as well. I think so. Again, Jinesh, the reason I'm saying is sensors. We are talking about monitoring. We are talking about generating data from the sensors, monitoring, and all those things. So again, from your perspective, what is that you are looking at, and how you're looking at the data collection and monitoring?
Right. So Samir, if you don't mind, I'll answer from a broader perspective as far as how the data goes for us, and then I'll dive deeper into the sensor and the backend side of it.
Please.
So we are looking at data at a broader level from 3 perspectives, right? The first one is the front end. front-end piece where we are looking at the customer, the markets, and things like that. Then I would talk about the mid-level, which is within the business, the data that transactional data within different departments and their own processes. And the third piece is the manufacturing, where we are talking about sensors and predictive maintenance and things like that. So from the front end perspective, every year we do operating planning. So we are planning for the next year. What that means is we are looking at, okay, what is happening in the industries that our customers are residing, right? What's the market trend within that area, ordering patterns, and things like that. So based on that, we can anticipate and forecast and resize our workforce in terms of supporting that. That's one aspect. Second aspect, obviously, we are looking at growth like every business is year over year, and we are looking at entering either the sub-segment within the market, or we are looking at high CAGR applications, right? High growth markets where we can align and grow with it. So the data, a lot of data comes from that end, which we analyze and then process and align with our core strength and identify where we can go and play and win, right? So that's the front end piece of it. Now, how that piece ties in with the rest of the business is if you talk about ordering patterns that comes through EDI systems and things like that. And we serve a variety of different customers. So we try to centralize the data. And that feedback is given to our from our product management teams to supply chain teams, because they will now have to plan for the inventory for the rest of the year, right? And as everybody know, inventory is such a mysterious subject where you cannot have a lot or you cannot have less, right? Because you have to meet your demand, customer OTDs and things like that. So that's how the front end data is tied with the business. The second aspect is we have key performance indicators that for each and every department, right? So every department is tracking their few areas, at least 4 to 5 areas, on how the performance of their department is impacting the overall health of the business, right? So part of that, if I can speak about the engineering, we are tracking our change management processes. So creating new engineering change request, changing the bombs, or creating new bill of materials and things like that. And we have established targets for us, right? So we are constantly tracking, are we on track, off track? If we are off track, okay, let's do a Pareto and identify what's the root cause and address with the countermeasure action so that we are continuously improving. So
Absolutely.
that's another aspect of it. Yeah. And the third aspect now, which is manufacturing, that's where the real-time monitoring of data, that's where the dynamic data comes from, right? So being a manufacturing business in Los Angeles, in California, with higher labor rates, we can't afford not to be super efficient, right? So we are constantly monitoring data in terms of manufacturing efficiencies, downtime. We are pretty big on predictive maintenance. So now, as we look through the lens of digital transformation, we are heavily relying on leveraging different types of sensing, which measures pressure, temperature, flow, speed, such parameters within different machines. And we try to, more often than not, we try to predict the machine performance and address it right away. That way we don't face equipment downtime and all those issues. And again, this data outside of machine, we also capture data in terms of the cycle time, tech time, and things like that. So if one line is operating at a higher frequency or a higher efficiency than the other line, we'd like to understand and solve that issue so that we are continuously chasing that optimum performance levels.
Thank you, Janesh. I think you gave me a segue into the next topic, because you talked about a lot of things on the technology and kind of predictive maintenance. I'm going to touch base on that side also. However, there's a question that I'm looking at right now, came from Rinesh actually. And the question is, what emerging technologies do you predict will shape digital transformation in manufacturing? How can industry players prepare to stay ahead? That's the question that has been put across on the question session. Again, Jinesh, since you were talking about that, Can I start with you on that? This is a very good question, actually. Thank you, Ranesh.
Sure. Yeah. No, I like that question a lot. So, if I can interpret that question, it's about what an ideal smart factory looks like, right?
Quite like that.
Yeah. So, a couple of points that I can think of along that line is one is uh, which should be a must, which is a data-driven core. What that means is you have to have the ecosystem in place which can collect seamless data and integrate from all areas within the factory, including machines, sensor, logistics, and even employee variables. Then you take that data and leverage advanced analytics and AI to generate real-time insights into production, efficiency, maintenance needs, quality control, and potential issues. And then data-driven decisions at all levels, from individual operators to management, fostering proactive and optimal actions. Second piece I would cover would be highly automated and interconnected. So this is where I can touch upon the robots and the cobots, which is a new term for the collaborative robots. They need to work seamlessly with human workers, handling repetitive tasks, specifically in hazardous environments and heavy lifting. Also leverage AMRs, what we call autonomous mobile robots, which can handle material transportation and logistics efficiently and flexibly. And then machines which can communicate with each other and with operators through secure networks, optimizing production flows and avoiding downtimes. Other area that I can think of is adaptive and agile, right? I think everybody at this point understands what the meaning of agile, but flexible production lines can cater to changing market demands and product customization. Digital twins, so you touched upon that, Samir, initially, that can simulate production processes and optimize them virtually before the real world implementation. So you can, debug it or improve upon it before you actually release in the system. And then AI-powered predictive maintenance to anticipate equipment failures and address them proactively. And the last thing that I can think of is at the core of it, which should be the human-centric approach, right? So it's not just about getting fancy tools and just implementing it, but you have to take care of upskilling and empowering the entire workforce, working alongside technology, focusing on higher value tasks and decision-making. Collaborative and safe work environment with clear communication and training processes in place, and then focus on employee well-being and engagement, leveraging technology to streamline tasks that reduces stress. So that in my opinion is a very optimum point, because you have to create that balance. You have to have your all employees on board anytime you are bringing on these new technologies.
Thank you. And Hans, I'll come to you because I believe there is a specific question for you. But I think I'll start with you on the kind of the future. I think what emerging technologies do you predict will shape the digital transformation in manufacturing is something that I want to start with, and then probably we'll jump to the question that is directed directly to you.
Okay. Yeah, Jinesh mentioned a lot of things that also are applicable in our industry. But on top of that, we all have our, let's say, environmental goals of our factories and our supply chain. And on top of what Jinesh is saying, you have to do it in a sustainable way. And with every factory or every organization nowadays has a net zero goal, and whether that is in 2030, 2050, or 2060, we have to go towards a net zero industry. So for me, right, sustainable manufacturing, but also design for sustainability becomes more and more important. When I look at our industry, years and years ago, we said, hey, we need to design for maintenance. So not only putting a machine there, but also that it's possible to maintain it. And then we got design for hygiene, design for sanitation, design for safety. But on top of that, now we get design for sustainability. And that is much more than only installing solar panels or a windmill or heat pumps. No, you have to go from the start of your process where you receive your goods until you ship it out and work with upstream and downstream with your partners to make the whole supply chain sustainable. So design for sustainability and sustainable manufacturing will get a lot more attention than it gets today.
Correct. And on top of it, Hans, I think there a specific question about which is directed to you is, could you share a specific example of how technology or innovation has directly improved a key aspect of dairy farming, and how do you think such advancements will continue to transform the industry in the coming years? I think question is specifically to dairy farming, Hans.
I guess so, and I have a bit of background also in dairy farming, and of course dairy farming is tough. Tough. Why is it tough? Because cows need 24 hours attention, and only a happy cow delivers a good quality and a good volume of milk. And what you see in the industry, where also it's very difficult to attract employees, that robotics in dairy farming is becoming more and more common. And we know that when a standard farmer milks his cows 2 times a day, but we know that you can increase productivity by milking cows 3, 4, 5 to 6 times a day. And that is where robotics come in. You have milk robots now. Cows are tagged nowadays. They have sensors. They go to the milking parlor based on their sensor. The gate opens and the computer has all the data of the cow. How many times she gave milk already, because you want to limit the number. You know where she is in her lactation. You know the shape of her udder, so that you can automatically put the milking robot onto the udder. And it increases productivity on the farm enormously, because you only need 1 worker per 250 cows when you go into robotics. But moreover, the quality of the milk and the volume of your milk increases. And I think that's an aspect that robotics will really help to drive productivity and quality on the farming side.
Thank you. I believe we. I hope we answered the question to you, Ashwin. The question was put together by Ashwin, so I hope we answered the question. And if you have any further detail that you want to check, you can put in the Q&A window. Ananda, coming to you on the previous question that I have, what are the tools and technologies that will shape or predict the digital transformation in manufacturing? So,
Yes.
and they want to be ahead of the curve. That's what the question is all about.
Yeah, sure. Yeah, the tools and the drivers of it, right? One is, of course, profitability of the company. Second one is the ESG, right, or the social responsibility. The third one, compliance. With world is changing, so every country has another regulations, the compliance. So there are tools that are going to help in that, right? Bring in the agility to us. And then some of them, so some events that happen, in due course of time also help some of these. One example is probably we all might have forget about COVID, but COVID helped in automation. I experienced it personally, and virtual collaboration. And third one is augmented reality. So I don't know how many of us before COVID used AR, VR to do basically simulations, remote training, maintenance, and training the remote workforce in locations where you don't have very technologists to even repair, maintain the equipment and help the production. So I personally experienced we had to expedite during the COVID time. So the technology of AR, VR helped us a lot in that. Right. So, and similarly, the robotics, right? That's evolving area. How to automate, right? Things that is done today manually, which is not only increasing productivity. Sometimes there can be hazardous areas where robots can help than humans taking that risk. And the blockchain of connecting all the dots and the data together, and Gen AI, of course, this is the buzzword. That's definitely going to change, because it's not, you don't need data scientists and PhDs. Even a regular worker should be able to utilize it. It will commoditize and democratize how you can utilize the AI.
Thank you, Ananta. So I think I have, since you stopped on AI, I'll probably start the next set of discussion points on the AI part of it. And hence, I don't want you to be going in the middle. I'll start with you this time. So you'll always be in that middle section. But I'll start with you on the AI part of it. So how do you see the AI part of it, including the Gen AI? I'm just saying, because Gen AI has been the buzzword for the last at least maybe around 1.5 years. It's been picked up. It's picked up like crazy. I think I want to, and especially after the launch of ChatGPT, I think it has become a buzzword with every single person whosoever is owning a laptop or a desktop. I think everybody knows about ChatGPT. So I'm just saying, how do you see the AI impacting the overall, I would say, Industry 4.0? I want to start with you this time.
Two areas. One is what is extremely important in our industry is asset reliability, and reduce unplanned downtime, because each and every day we have to process that volume of milk, and shelf life of farm milk is very short. So what we use is in our rotating equipment, real-time condition monitoring, where we put sensors on machines that register vibrations, that register temperature, environment noise, and all that data is collected, and that data is compared with similar assets all over the world. And based on, let's say, AI, data analysis, it helps us to, in an early stage, see when an asset will break down when we don't maintain it or do preventive maintenance. And because the assets that are monitored all over the world, there's a lot of information, very useful information generated that we can use in our factories to optimize our preventive maintenance. That's one part. And other part where I see AI really helpful is in product development and in product innovations, where you do based on consumer insights in the industry, can accelerate your innovation process. And I think that's something that becomes more and more available, more and more required to increase the pace of innovation. I lived in China for a long time, and when I see the pace of innovation in consumer goods there's a lot we can still learn in the US from that. And I think that AI will be extremely helpful in increasing the pace of innovation.
Thank you. And one more, I think I just give you a data point before I go to Anant. I'm coming to you. As per a very latest Gartner report, the largest data in 2023 was generated by the manufacturing industry. It was 1,800 petabytes of data that was generated purely by manufacturing, because Hans also talked about the data, AI, and everything is based on data. So I'm just giving you one data point. 1,800 petabytes was generated by manufacturing industry. The second biggest generation of data happened by the government sector, and which was 900 petabytes. So just half of what was generated by manufacturing. So again, coming to you, Ananta. So I want to talk about a little bit on the AI, the Gen AI that you mentioned. So I would request you to kindly elaborate on what your thought process on AI, Gen AI in the manufacturing 4.0.
Sure. So AI is not new to the industry, right? It was not democratized, rather, right? It was more of an engineer's job. But when Gen AI came in, and everybody starts on this, oh, I can use it, because it's more like a text, right? It's a text search. So from AI and ML, right? I'll go back to even actually ML models. the data that we have in vertical manufacturing that we collected, you talked about the data sizes, right? We have about 15 petabytes of data in our manufacturing today. It can be
So
very,
out of 100, you are generating that majority of the data. I can see that. So I'm just
that's varying types of data. Right? It's not, the challenges of the data is it's not just a structured data. It's basically it's a text data, it's a parametric data, it's image data. Of example, wafers, right? We collect images, and we have to apply the maps on top of it. So that's where our engineers use the ML models to analyze the data, and then basically one is analysis, second one is as I mentioned earlier, fail fast, so that we don't get it to the next level. Wafer going into a transceiver is basically a big loss, right? We do that. And apart from that, the product innovation, right? What's coming new, right? What what market needs? How can we be ahead of the curve? That's the second area. And Gen AI is helping a lot compared to these machine learning AI models. So that's why we are working collaboratively with our CTO office and our engineering team. And that I expect that's where we are going to be. I mean, it gives us a competitive advantage. Apart from regular usage of productivity, right? We can use co-pilots for all the regular employees where the day-to-day tasks are automated, their meetings, they don't have to take the notes, everything is automated. Those are regular usages, but critical for for our enterprise is the helping in the product innovation and the lead time, reducing the lead time to the market.
Thank you. Thank you, Ananta. So, Jinesh, I'll come to you. But before I come to you, I think there is one question that is there in the Q&A window, and which may be directly pertaining to the point that you mentioned earlier also. The question is, in manufacturing industry, IoT machines normally generate more data points. Can you share guidance on how to filter necessary data from the data pool for predictive maintenance defects? So, Jinesh, I'll come to you. I think it's important that how to kind of assess the data specifically for the predictive maintenance and defects, and then probably we'll discuss a little bit more, because that's my next topic on the topics on the tools. Like IoT, I consider as one of the tools that we are using. So I think let's start with the data for let's say using AI, ML, and predict for the preventive maintenance and defects, and then we can jump onto the IoT as well.
So conceptually speaking, without diving into a specific tool for data analysis or analytics, I would say the first and the foremost thing is you have to be cognizant about why you are collecting the data, right? Are you trying to solve one problem, or are you trying to do real-time monitoring, and you're leveraging that data to make certain decisions in real time, right? More often than not, it's about either one of these problems that we are trying to solve. That's number one. Second thing is, which variables are you measuring, and are they pertaining to the problem that you are trying to solve? So once you answer these two questions, you are already being intentional and cognizant about not overloading your systems with tons of data, which may not be either applicable or relevant, or may not be as important as the other variables that could play a part. So that would be the initial step that you can take of being cognizant about what data you want to take. That's number one. Number two, so during 24-hour shift or 8-hour shift, however or whenever your machine is operating, is it required to collect the data during that whole 8 hours, or is it necessary to collect the data regarding certain operations or during certain time of the day? And you can probably start with collecting data initially on everything, and then once you have certain level of Paretos where you see problems during certain time of the day or while doing certain operations, you can start to narrow down your problem that way. And that way you can avoid the issue of having too much data, because too much data is also not good, because how are you going to analyze? I mean, of course, you can start to write complex algorithms and also put in a layer of AI, ML on top of it, that you can identify different patterns within the data. But to me, being cognizant about how much to measure and what to measure is also critical.
Janesh, you also mentioned in the last discussion on the predictive maintenance. Can you elaborate a little bit more on how are you using data for the predictive maintenance for it? I just want to, because I think Ganesh's question was more on the predictive maintenance side. So we can integrate both data and the predictive maintenance. If you can actually talk a little bit more about that, please.
Sure. So without getting into a perfect example of how we are doing, I'll just broadly speak, and it could be a lengthy response. So bear with me. So I'll present 10 quick points, and I'll also try to integrate your point, Samir, on how we can leverage AI also part of this predictive maintenance, right? So the overarching goal of any manufacturing business is to keep the uptime so that you can be efficient. Number one. Number two, you can manage your cost, and number three, you have to meet your customer matrix, right? Your on-time delivery, because that is the single most important thing in this day and age. So now, if you layer on top of AI, there are I think 10 different benefits, and I'll speak in terms of the predictive and preventive maintenance, right? So the first one would be the data analysis, which we just spoke about. The AI algorithms can process vast amount of data from sensors and logs to detect patterns that precede equipment failure. Second thing it can do is anomaly detection, which machine learning models can identify deviations from normal operations, which may indicate the early stages of the problem. So you can solve it before the loss of efficiency. The third is predictive modeling. By using historical data, AI can predict future failures, enabling maintenance to be scheduled before a breakdown occurs, which is a true predictive modeling, right? The fourth piece is optimization of maintenance schedules. So AI can optimize these schedules, ensuring that maintenance is done only when necessary, rather than on a fixed schedule, saving time and resources. So instead of being a time bound, it's being cognizant about exactly when you need it, and that's where you can invest time and energy behind that. The fifth one is real-time monitoring. So AI systems can monitor equipments in real time, allowing for immediate responses to any detected issues. The sixth one, which I think will resonate more with Hans, with his expensive manufacturing assets, is about extending equipment life. So by preventing excessive wear and tear through timely maintenance, AI can help extend the operational life of your machinery. So you can get the more ROI out of your investment that you made on specific assets. Cost reduction. Predictive maintenance can lead to significant cost savings by avoiding unplanned downtime and extending the life of the equipment. Safety improvement. By preventing failures, AI also improves the safety of the work environment, as unexpected machine breakdowns can pose risk to the operator. So if you can predict it, you can solve it before an accident happens or occurs. And then integration with IoT, which is the integration of AI with IoT enables smarter predictive maintenance by using connected sensor and devices to provide real-time data. And last but not the least is the customizable solutions. So AI models can be trained to specific equipment and environment, leading to highly customizable, predictable maintenance solution tailored to the needs of different industries.
Thank you. Thank you, Dinesh. Hans, I'll come to you again on the IoT or the IIoT piece of it. I'm not sure. Again, this is what I want. I was inquisitive about the use of IIoT in the dairy industry, and the reason I'm asking this question is, again, as per a McKinsey report, now I'm quoting, 63% of the manufacturing company believes that IIoT will increase their productivity by almost like 35%, increase the not productivity but the profitability by 30 to 35% or more in the next 3 years. Now, I think, and in the last 2023, I have a data point, there were almost like $50 billion investment that was done in the IIoT. So again, Hans, I'll start with you. IIoT or / IoT, are you using that in your setup, or you have seen that implement going forward? Are you planning to implement that in your setup, please?
Yeah, I must say we are the whole dairy industry is a rather conservative industry, and we are not really applying it. We are thinking about it, of course, but we are more in the stage in what Dinesh shared. really focusing on uptime of our assets, and that will increase productivity and has proven to increase productivity a lot over the past years that we are working on it. Predictive maintenance, but also predictive controls, where more or less you take the decision out of the hands of the operator by giving him proposals how to optimize, how to run your machines. And when you look at the spray dryer is a $50 million asset that has a lifetime of 50 years, hopefully, when you maintain it well. And optimizing that, at 2/10 more moisture in your product can make a huge margin impact. So helping operators with the help of predictive controls and AI is really improving margins and productivity in our sector. But we are rather conservative, what I mentioned. So there's a lot to do for us.
Thank you. And Ananta, I'm jumping onto you again on the same topic, IoT, IIoT. How are you seeing that in your setup or in your view? How do you see it from the Industry 4.0?
Sure. So IoT and IoT in the equipment in production, right? I would agree with Jinesh. All the top, he covered almost every aspect of it in this. And one other thing I would add there is it's not just about the equipment; it's about the entire production line. So, example, one of the equipment may be problem, but you want to make sure that you predict beforehand and then also optimize your production line rather than just basically that just one equipment then become a bottleneck, right? Because bringing down the entire efficiency of the production line, right? And that's on the equipment side. On the other hand, you can even embed IoT into products. For example, we sell product to the customer, and even before customer knows that there is a problem with the product, if we can sense it and then call the customer, hey, there is a problem, we are working on it. The experience of the customer is a game changer, and that's a vision, right? I know it takes time, right? And example, we are seeing right now EV cars. So how much data it collects? So, and in some ways, we are in the middle of it, though we don't, the people don't see us because we are, we supply components and some of the sensings. I think those are the areas I think is going to come. It will be reality because of the EVs. I see some of them are already coming in, and also other industrial sectors also it will come through.
Got it. And another on the same topic, I'll start another thread with you. I think in one of the previous discussion point, you mentioned about the AR VR component of it. I think the wearables, the AR VR. So I want to kind of go into depth of how are you using AR VR? What are you seeing again as a trend on the AR VR side of it? And then I'll go to probably Jinesh and Hans also after that, please.
So one is restrictions we had. That's when actually it started the need, or we felt that it's absolute need. An example, we have factories all over the world, like Asia, but we have most of the sophisticated technical staff are in US. How can we even observe if there is a problem with the equipment, even problem with the product? So having the AR VR, one is zero lead time, real time. We can work with the other side, and also it's all built into the ecosystem, right? We don't have to worry about our data going out, and it's within our network, and we can real-time monitor, have the collaboration, and also fix the problem. And this will reduce the other expenses, the travel that we have, and the time to fix the problem, and of course, operational improvements and profitability. The end goal is always for an enterprise.
Absolutely. And I think we are seeing a lot of use cases of wearables in terms of maintenance, as you mentioned, because people can view those things sitting remotely and see how they can fix those things. I think I'm apart from only in the industry of manufacturing, I'm seeing a lot of use cases of AR VR in the medical segment where we are actually using it for our medical devices and all those things. So again, medical devices are considered as a small subsection or sub-component of a manufacturing industry because it's a devices manufacturing. But again, I'm seeing a lot of AR VR on that side. Hans, coming to you, I know you are. I think the way that you explained about the robotics that you are using for your dairy farming or from the cows and all those things. I want to again check with you on the AR VR. Are we planning to use the AR VR, the wearable technologies, as part of the dairy industry?
Yeah, we are using those, and it started during times of COVID, where travel was very limited, and we started using AR VR glasses, especially in our maintenance departments, where technicians could go into a failing asset and have contact with an expert in our company, or with a vendor, or with another expert, so that they can real time see what is happening, giving instructions, getting drawings up. And that really helped us, especially during times of COVID, to limit our breakdowns and reduce our time to repair.
Thank you. And Jinesh, coming to you.
Since that time, and one of the good things that happened during COVID, of course, that you see that it helps you to reduce downtime, it reduces cost at the same time. So there are a lot of benefits that we, most probably without COVID, would have taken much longer to discover.
Absolutely. I think that makes a complete sense out of it. So Jinesh, coming to you, are your views on the AR, VR and the wearable, please?
So AR VR could be a subset under the broader category of wearables, but if I have to focus specifically on AR VR,
no. I think wearables is what I was talking about basically. Yes, you are right. AR VR is a small subsection of the wearables you're talking about. Yes.
Okay, so maybe I'll start with the wearable side and then maybe give a little overview on the AR VR itself. So wearable technology, or you can also replace the term by saying smart clothing, that the operators can leverage. So now these devices can be anywhere from smart watches that alerts workers of safety issues or provide instructions, to exoskeletons that can assist with lifting heavy items or let them work in a hazardous environment and prevent a risk of injury. The smart clothing can be designed with embedded sensors that can monitor vital signs, detect excessive heat or exposure to toxic substances, and provide haptic feedback for trainings or alerts. These wearables can also be integrated with factories' digital ecosystem, providing a wealth of data that can be used to optimize worker deployment, improve safety protocols, and enhance overall operational efficiency. So I know usually when we talk about wearables, we are in general looking from the consumer space, but definitely in the industry there are several benefits to it. Right now, if I have to talk about AR and VR, part of that subsegment, the way we are not using it currently, but at least in the future when it becomes a little more easy to implement. Mainly two areas that I can think of. One is obviously the operator training, and second, even during the assembly process. And why I think could be really helpful and useful and absolutely needed is because gone are the days where you set up a fixed manufacturing setup where you are cranking your production day in day out, same thing, right? Over the last several years, we have seen that industry now demands customized solutions. As a matter of fact, our business, that's our niche, and that's our competitive advantage, that we provide this customized solution. What that means on the production floor is now you have high mix, low volume production lines, right? In that context, now training the operators, providing the visual work instruction becomes a real challenge. Now, in this scenario, think of providing them with an AR/VR headset. They don't have to worry about or know what the instructions are. when that product comes to their station, the VR will detect what it is, what part you are building or what assembly you are building. It's going to give you instruction, okay, pick up this retaining ring or pick up this part, assemble it this way. So that, I think, would be, in my opinion, would add real
That's
value.
happening. I think that's a good one. Yes. Thank you, Janesh. And I think this is very important per se, because I believe you were absolutely right. I think most of the people, like uh, a general public, I'm saying, they look at wearable only from the wearable glasses kind of a stuff, right? The Vuzix and all those, the Meta glasses and all those things, that your Apple
Correct.
glasses. But I
That's
think
what came to my mind.
that's where I think you and everybody from a manufacturing setup changes the perspective of the connected devices. And you mentioned about the wearables with the sensors on it, and the IIoTs that we were talking about, all the connected devices and wearable that can generate data, whether it is the temperature, as you mentioned, or the vitals data and all those things, and how can then be used for actually the benefit of the humans that are working out there, or benefit of the overall I would say value chain, I would say. Okay, wonderful. I have a couple of more points that I will discuss. There are a few more I'm saying I think discussed about the robots. I think that's what is we talked about, the robots, the chatbots, the cobots that we are talking about, and the automation that we are doing. I think the more important component that I want to discuss was the marrying of the AI and the wearables that I consider as digital twin. And I think that is one thing which is sweeping across our manufacturing industry right now as a part of it. And I think I'll start with an example and then probably go around the table, starting with the Ananta. The example is I was talking to one of the CIOs on the I would say the oil and gas industry, and they were talking about creating 100% digital twin of the oil rigs. There are oil rigs in Norway. There are oil rigs in Alaska. There are oil rigs in Texas. Every oil rig is different, because the one in Norway is in the middle of the Black Sea. The one in Alaska is in the middle of the mountains, or in somewhere in the cold, very harsh, cold places. And one in Texas is in a plain field, which is like hot area, plain fields out there. So what they cannot send people out there in the middle of the North Sea to kind of see what's going wrong. So what they have done is they have created digital twins of all those oil rigs, and they are doing all the preventive maintenance or the predictive maintenance, checking what's not working. As Jinesh, you mentioned in one of the things, the correlation of the data out there, predictive kind of stuff when things are not going right. So that's the example that I would use for digital twin. But I want to start with you, Jinesh. Are you planning to use digital twin, or are you already using digital twin in your setup somewhere out there?
No, we are not using yet, and we are not planning to use in the near future. But I do see the benefit. I do see the benefit for the overall industry, and specifically one area where I can think of where some of our energy segment customers are these oil wells and rigs, and those environments could really be hazardous. Nobody wants to go there, and it's expensive to send people there for predictive maintenance, periodic maintenance. And I think if I'm not wrong, I believe Siemens and Schneider Electric, they also went pretty heavy on creating this digital twin concept. I think Rolls-Royce also did that for aircraft engines, where they can the digital twin will actually simulate what's happening in the field, and will give you the insight in terms of predictive maintenance and extending the life of the equipment and things like that.
Absolutely. Ananda, coming to you, please. Digital twin.
Yeah, so our environment is not as tough as oil industry, because we sell the networking, lasers, and materials.
I know.
Yeah. Without saying defining it basically between human technology, data. Yeah, we use them right in one form or other. Definitely we use it at this time. But in my view, the time, right? So some of these technologies are there for long, but they're more in a conceptual stage. The ecosystem is not there today. We have the example. Are we talking about all the Gen AI, or even the wearable? We have the compute. We have the networking capabilities. We have the storage. Storage is cheap, so that is a prime time. And we have seen the industry revolutions, right? Because when Amazon came in on the marketplaces, the number of players came in, but they struggled for a long time. But there are few companies that emerged, they are the leaders. And now we see NVIDIAs of the world that's coming up, right? 10 years ago, NVIDIA. Today, it's very different.
Yeah.
So
no, absolutely.
This
it's
time for these technologies.
No, absolutely. And you mentioned NVIDIA. It's looking at the stock price. I think it shows the results out there right now. NVIDIA stock price is shooting up. Coming to you, Hans, any thoughts on the marrying of digital? I would say the AI with the wearables in terms of digital twin or something of that sort.
We're not using them, but we will in the future, and especially in product development. And why is that? Because when we develop new products and you want to run them in a factory, the scale is enormous, and you need a lot of very valuable factory time to do trial production. And we think that in product development, with developing digital twins to simulate our production processes, we can accelerate, but also save a lot of cost. So that is one area where we are more or less exploring how it can help us in the future.
Okay, got it. And I think one of the areas where I also did some digging out there was the digital twin of the supply chain. I think that's where people are creating a digital twin of some of the processes out there, especially on the supply chain. They're using digital twin. They are also, I think, creating visibility through blockchains out there. I think there are some areas where blockchain is being implemented to kind of enhance the collaboration between the suppliers, the vendors, and the factories out there. So I think those are the few areas that I'm seeing some things out there. I'll touch the last two topics. I know we have 10 more minutes, but I'll touch the last two topics. One is on the, I think our entire manufacturing industry has been a very, very labor intensive. So looking at the next generation of the people who are going to be part of our overall setup, the team, the manufacturing team out there, how are we ensuring few things? Obviously, the skills. How are we making them adapt to the new technologies, new skills out there? I know we talked about wearables. We talked about taking care of their security and this thing. So that's one topic which I want to start with probably Ananta, you. And then finally, we'll wrap this session up with the ESG, or the environment sustainability, is very key component, as Hans mentioned. So we'll start this on the human side first, or the skill side first. And then Hans will start with for the environment sustainability with you after this part. Yeah, over to you, Ananta, please.
Oh, great question. So one is building the digital culture, right, with the existing staff. Right? And in manufacturing industry, it's difficult compared to a technology company like Google, and it's easy for them. So the building the digital culture, and it should come top down, right? It's not bottoms up. It's a top down, and first practice and preach to the team, and also to combine the teams, attract the young talent, right? Example, bring in the interns. So bring these two groups together, and so that each other appreciate what others know, and then what technology can bring in. That's and also manufacturing industry is always a cost pressured industry. It's always, we are driven by cost. We got to make sure that we cut down the manufacturing side, of optimize it so that we maximize the profit. So and only way to do that is automation, optimize the bombs, right? Using the technology, what alternate components can we use, and then optimize the manufacturing process. Right? Yep. And so it's more of a bringing that culture into the teams and explain, and so that they realize that it's going to help us, and also bring the current staff and the younger generation together.
Okay, got it. Thank you. Hans, your views on the upskilling of our human capital?
Yeah, with all the, let's say, new technologies and new automation, we need a next generation of employees that are capable of doing what we expect from them. And I think that is one of the main challenges we have, to get the right people to do the jobs that are required. And we're spending a lot of time and money during the recruitment, that you have the guys that have that change mindset and that can grow into your company. It's not about the skills that they have at this moment, but it's about the skills that they need in the coming years. So in your selection process, you need to recruit guys and operators and supervisors that can help you in the coming 10 years.
Thank you. And Dinesh, over to you. Any thoughts on the human capital and the leadership and the culture?
I think it always starts with the leadership, in my opinion, because they are the architects who create the culture. Otherwise, the culture creates itself. That's how I say it. But yes, digital transformation in a nutshell, or any initiative, it has to come from top down, and it has to be executed in a way where it's all hands on board, rather than how it feels like, okay, you are putting the initiative down on us. Instead of that, it has to be a collaborative approach across the board, where you have you don't just start with, okay, we are going to do initiative 1, 2, 3, and this is how we are going to do it, rather than these are the overarching goals, and let's figure out together what's the best way of doing it. So that's one aspect of it. Second aspect, you mentioned about upskilling, right? So it's not always ideal to find employees or operators who are already skilled with this new technology that you're gonna keep it part of a hiring process. But we have to be open to and investing to that training upfront. So the model that we currently use, at least for office employees, is 30, 60, 90-day training. That's an onboarding plan. And the new employee or the new hire will go through the training or the videos through our processes, through our culture, through our product, application, market, all that training, right? So now with the digital transformation and the new skills, you just add that layer onto that. So that can be seamlessly integrated. But yes, the upfront work is needed to create those training modules on the technologies that you're using.
Absolutely. Thank you. And the last topic, I think, Hans, you did a very fantastic job in the middle of the session on the environmental sustainability. I think I want you to kind of help us put some light on that. What are the things that you are doing from an environmental sustainability standpoint?
Okay, when you look at our overall supply chain, our issue is not in our factories, but on the farm side, where of the 100% of emissions, 90% almost is on the farm. Focus on there you can do a lot in feed additives that you can do to reduce emission, but also all kinds of robotics, manure processing, digesters. On the farm side, a lot of initiatives. When you look at our factories, what I think what is most important, that we apply that design for sustainability concept, that in every improvement we do in our process, we are not only thinking about safety and maintainability, but also about sustainability. So how can we change our setup in our factories to become more and more sustainable? And especially when you build green fields, take sustainability as one of the highest priorities.
Absolutely. Anandan, last few thoughts on sustainability, please.
Sure. Yeah. So a year ago, we didn't have sustainability as a separate partner. A year and a half ago, right? It was part of operation. Now we have a chief sustainability officer. So we work closely with one of the alternate utility suppliers for fuel cells, and majority of our factories, we have the fuel cells as a supply source for our utilities. So, and actually in some of those meets, actually our CEO was one of the key speakers promoting the sustainability, along with that. And apart from that, we measure our utilities or the water usage, the carbon emissions. We have partnered with the major vendor, one we were talking about earlier. We measure, and then we have goals every year, and it's it goes all the way up to the board, that we report to the board, and we have targets.
Wonderful. Thank you. Gents, I think we are on the top of the hour. I'll just summarize a little bit. I just noted down some of the points. First of all, I think we had a wonderful discussion on the digital transformation. I think starting with the cost optimization, I think I was reading some of the articles earlier also. I think what we are trying to achieve, apart from the innovation and the transformation going to the next level of Industry 4.0, we are looking at a reduction of inventory holding cost by almost like 15 to 20%, labor productivity improvement by almost 30%. We are looking at preventive maintenance, bringing our machine or downtime by almost like 30 to 50%. We are also looking at improvement of our throughputs by 10 to 30%. Again, I'm saying improvement in forecasting accuracy. I don't know whether we discussed about that or not, but they are looking at improvement in forecast accuracy by 85%. That's a huge number, but that's an improvement I think they are talking about. And obviously the cost of quality. I think that was part of, this is all beyond the new ways of working for Industry 4.0. This is what we are looking at. And to sum it all, we are looking at a very good sustainability out there. So thank you, gents, for the discussion. Thank you, Arvind, for coordinating with the team for this discussion. Really appreciate your time and the insightful thoughts. Thank you very much, guys.
Thank you.
Likewise. Thank you, guys.
Thank you, Samir. Thank you, Jinesh. Thank you, Hans and Ananta, for this engaging and informative session. I trust the audience would have gained a deeper understanding of this topic. So before we conclude, I would like to thank our community partners, speakers, attendees for enriching knowledge through this forum. Our panel speakers have shared their insightful thoughts, making this webinar a valuable experience. For your information, today's webinar was broadcasted live in our YouTube channel, and the recording will be available for your reference shortly. Also, please visit our website, aicospot.io, and follow our social media handles for upcoming knowledge sharing topics and events that will expand your awareness. So I would like to extend my sincere thanks to our knowledge and innovation partner, InfoVision, and the technology partner, Digit7, for contributing towards making this webinar a huge success. Thanks a lot, everyone, for joining this webinar, and have a fantastic day and weekend. Thank you.
Thank you. Thank you very much.
Thank you.